First of all, what is the criteria for optical activity, or when we can say particular compound is optically active or not? So there are three criterias. What are these? Compound should have chiral carbon. That is the first criteria. Second criteria is compound should have non-superimposable mirror image. And third one is compound does not contain any element of symmetry. So there are three criteria. Again, I repeat. First one is compound should contain chiral carbon. Then it has non-superimposable mirror image. And third one is it does not contain any element of symmetry. First two criteria we already know. We already know what is chiral carbon. We already know what is non-superimposable mirror image. Okay, so what we doesn't know is what is the meaning of element of symmetry. Okay, so there are three types of symmetries which are we going to study. So if compound contain chiral carbon, but if it contain element of symmetry, then that particular compound is not optically active. So first element of symmetry is called plane of symmetry. So there are three. First one is plane of symmetry. First I read this and I will show this on a whiteboard also. So plane of symmetry is nothing but imaginary plane that passes through a middle of a molecule in such a way that one part is exact mirror image of another part. So plane of symmetry is nothing but it is an imaginary plane, passes through a middle of a molecule, and when it passes, then one part is exact mirror image of another part, and that is called plane of symmetry. Let's check this example on a whiteboard. We take example of mesotartaric acid. So I draw its structure. Contain two chiral carbon. This is first one and this is second one. Okay, so this compound contain two chiral carbon. Okay, so if it contain chiral carbon, then it should be optically active. Correct? Mesotartaric acid should be optically active, but it is not optically active. This compound, mesotartaric acid, is not optically active because it contains plane of symmetry. What it contains? Plane of symmetry. So what is this plane? So this is nothing but an imaginary plane, passes through the middle. Then you can say this, the upper part is exact mirror image of lower part. Next type of symmetry is called center of symmetry. Now what do you mean by this? First I read and then I will show this same on whiteboard also. So center of symmetry is defined as a center or a point in a molecule from which lines drawn on one side and then produced to equal distance, then that line meet exact at similar point in the molecule. So all the lines meet at the same point, similar point, and that's why this is called center of symmetry. Then this is the chiral carbon, this is the third chiral carbon, and this is the fourth chiral carbon. So there are four chiral carbons are there. Now this compound contains four chiral carbon, that means it should be optically active, but it is optically inactive. Now why it is optically inactive? Because it contains center of symmetry. So I join, first I give number to the carbon atoms. So 1 and 3, these are opposite, and carbon number 2 and carbon number 4 are opposite. Carbon number 1 and carbon number 3 contain methyl group and hydrogen. So first I joined methyl group, then I join hydrogen. Okay, so it is for carbon number 1 and 3. Then I join carbon number 2 and carbon number 4. There is a hydrogen atom. Then there is a acidic group. So what you can observe here, our observation is all lines are passes through this similar point, right? So this is called center of symmetry. I hope everyone understand this concept. So number 3 is alternating axis of symmetry. This is very interesting. A molecule is said to possess alternating axis of symmetry or rotating group or angle of 360-degree about its axis and followed by its mirror image. Then the mirror image is exactly identical to the original molecule. Then it is called alternating axis of symmetry. Now what do you mean by this? As you can see here, this is the molecule, right? When this molecule rotates through an angle of 360 degree upon n will be any number 1, 2, 3. So 360 divided by 4 equal to 90 degree. You can rotate it through 90 degree, 180 degree, or 70 or 270 degree, etc. So after rotating, we get this molecule. Now what we have to do? We have to take mirror image of this compound. Now if mirror image and original molecule is same, if mirror image and that particular molecule is same, then we can say that that particular molecule contain alternating axis of symmetry, right? So if any molecule contain alternating axis of symmetry, then that particular molecule is optically inactive. Instead, it contain any number of chiral carbon atoms. Let's study this example on whiteboard so that you can easily understand the concept. 2, 3, and 4. Now we have to rotate this molecule through a how much degree? 90 degree axis. We have to rotate this molecule through the 90 degree, right? After rotation of 90 degree, what you get? You get this molecule. So we have to take mirror image of this. After getting mirror image, what mirror image we get here is this one. Now you can see I give number to these molecules 1, 2, and 3. Okay, what do you observe? Number 1 and number 3, these are same, right? So this is called alternating axis of symmetry. So students, so this is the concept of alternating axis of symmetry.